we are ready. First one in line, it's your turn.
Good, thank you. All right, hello everyone. I'm Doug Blomquist with Sandia National Labs in the USA. In this study, we conduct higher frequency calibrations of 6 models of seismometers commonly used at IMS stations. The goal is to better understand how the seismometers perform at higher frequencies and how well our measurements match nominal response models provided by the manufacturers. The study was conducted in 3 parts. In part 1, we investigate how calibration results are impacted by the coupling between the seismometer and the surface of the shake table that's used for the calibration. In part 2, we use modern shake tables to perform primary ground motion calibrations of the 6 models of seismometers. We repeat all calibrations many times to ensure results are stable and repeatable, and then we compare our ground motion response to the nominal response models provided by the sensor manufacturers. Finally, in part 3, we carry out electrical calibrations of the same seismometers. We remove the ground motion response, which we measured in part 2, from the electrical calibration data so we can determine how the calibration system itself responds. And again, we compare that to manufacturer specifications. Thank you.
Good morning, ladies and gentlemen. My name is Gleb Zasimov. I represent all Russian Research Institutes of Automatic, a state of Rosatom, Russian Federation. So I'm very happy to be here, and my colleague too. We present our poster during session 3.1, number poster 3.1-182. On the screen you can find number 4. And our institute has developed scientific and methodological support and hardware, software for OSI. Also, we has developed short period vertical seismometer and 3-component broadband seismometers for seismic monitoring system. Also, has generated protective coating for scintillation battery detector to reduce diffusion of the analysis radioactive gas into the material of the detector cell, and other very interesting developers. So if you want to discuss about it, please come on our session. I remember on the screen number 4. We'll be happy to answer your question. Good luck. Thank you very much.
Good morning, ladies and gentlemen. My name is Pavel Martisevich, work in CTBTO Engineering and Development Section, IMS. And today we would like, with my co-authors, present our progress in the noise study examples for infrasound stations. So the recent developments in infrasound noise models and progress in digitizers and microbarometers design allows to introduce precise infrasound noise studies, which was not possible before. And our section has compiled a depository of equipment self-noise data and background infrasound noise data of IMS infrasound stations. The presented noise study charts show the results of our studies and multiple IMS stations, and the outcome may suggest as well revision of IMS minimum requirements for infrasound station specifications. So you are welcome to look at our poster and present your comments, observations. Thank you.
Hello, everyone. My name is Matsumoto Hiroyuki from Jamstech, Japan. This study is focusing on the seafloor observatory system in the Nankai Trough seismogenic zone. And 2 Donet seafloor observatory systems have been installed by the end of 2016. Additionally, we installed 3 borehole observatories and 2 seafloor observatories. In my presentation, we introduced the fiber optic stream meter of its installation and extension performed last year. If you are interested in this topic, please come to my poster booth. Thank you very much.
want the video? Do you want to show the videos at the end? Okay. You want the video shown at the end? Okay.
You can choose the video too at the same time, the poster. Okay, all right.
Can you let the next speaker speak in the meanwhile? Can you let the next speaker speak in the meanwhile?
Hello. Yeah. So good morning, everybody. I'm Fabrice Lepoint. I am happy today to show you our last development of a seismic sensor. This seismic sensor uses an interferometer, and thanks to some mechanical choices, this seismometer is able to measure, to have a self-noise below the seismic low noise model, minimum 20 dB below the seismic low noise model from 1 day of period up to 20 Hertz minimum. This seismic seismometer there is vacuum inside, and that's why we have such low noise at low frequencies. So this seismometer, you can see it at Seismowave stand, and I will be happy to answer your question. Thank you.
Hello, everybody. My name is Andrea Tola, and today I represent National Institute for Earth Physics. And I bring to your attention a study case about the influence of the atmospheric condition on the ambient noise, ambient seismic noise. In this study, we examined the relationship between the noise level and weather parameters for the stations where seismic sensors are collocated with the weather sensors. So if you want to learn more, I will be at the touch screen number 11. Thank you very much.
Thank you.
Good luck.
Thank you. Good morning, everyone. Over the last 40 years, various broadband sensors have been designed, and most of the broadband sensors have avoided the high frequency end of the seismic spectrum. And at Gaia Code Limited, we have redesigned a particular type of broadband sensor which allows us to be able to cover 5 decades of frequency response, starting at 360 seconds all the way up to 277 hertz. Single view instrument which covers the whole broadband sensors. And during the poster session, I'll be able to inform all of you of the different changes that we have generated within the broadband sensor to achieve this wide broadband response. And the product is available either as a borehole, surface, or a post-hole instrument. Thank you very much.
Okay, hello everyone, good morning. My name is Thomas Bruns. I'm a vibration metrologist by profession, and I'm here as the coordinator of the InfraAUV, the EU-funded project InfraAUV. Within this project, we are developing calibration methods to provide traceable calibrations from a primary lab up to, over a chain, up to the IMS stations for infrasound, underwater acoustics, and seismic. And in our poster, we focus this time here on the primary calibration of seismometers, why we do it, how we do it, and what the challenges are. Calibration in this event, or in this time, means what you would call ground response determination, maybe. So it's the calibration of the seismometer response to external motion. It's not the electrical internal calibration. So if you are interested in this development, please visit us at the poster. I'm looking forward to it. Thank you.
Good morning. My name is Marvin Rust. I am also part of the InfraAUV project, this time in the infrasound region, and our work is concerned with the primary calibration of microphones. For this, we utilize the vertical gradient of the ambient pressure, so we calibrate microphones by moving them up and down, and an apparatus called the microphone carousel. And if you want to know more about this, please show up at my poster. Thank you.
Hello, I'm David Harris. I'm with Hyperion Technology Group. We are a manufacturer of infrasound sensors. We do provide infrasound sensors for some of the IMS stations, realizing the need for a ability to verify calibration without having to go in the field and remove sensors. We've been working in conjunction with the NCPA, National Center for Physical Acoustics at the University of Mississippi, and developing a source signal that's located with the sensor, allowing you to validate your calibration and feel good about it without having to necessarily go out in the field and remove the sensor for calibration. Infrasound calibration requires specialized equipment, and it's not practical for some of the locations and that these IMS stations are actually located in. So if you'd like to see that and know where we're at on that and how we're moving towards integrating that into our sensor systems, by all means, come see us. Thank you.
Hello, everybody. My name is Leonid Zimakov, and I represent a company named Advanced Seismic Instrumentation and Research, or ACER. In my e-poster presentation, I will show the results obtained from our advanced borehole broadband seismometer model ABB, which ACER designed with the silicon audio interferometer-based accelerometer, which can be deployed in the downhole downhole well at a depth up to 1,500 meters. So the frequency flat response of the sensor is from 125 seconds to 1,200 hertz, with the clip level either plus minus half G or plus minus 2 G. Dynamic range of the sensor is 172 dB. Deployed in a different depth in a downhole well, the sensor capable to record the microseismic event with the magnitude less than -1 in the near field and magnitude greater than 4 in regional or teleseismic distance scale. So in my poster, I will present the waveform of the microseismic induced event recorded by the ABB sensor deployed in a 1 kilometer depth borehole well at Swiss nuclear depository site. So please stop by my e-poster, which is displayed in monitor 19, to discuss the sensor design and specification in more detail. Thank you.
Sorry for the delay. So my name is Olivier Rousseau. So I'm working on an optical base interferometer for sensor and mechanical seismometer. So there is a moving mirror, which is interrogated by a laser. And from this, we obtain a rotating Lissajous curve. The angle of this Lissajous curve is proportional to the displacement of the mirror. And so we register the angle with time, and we extract the displacement of the mirror. So we can show that this displacement is well below the low noise model for displacement. And it's a good accuracy on the sensibility of our sensor. And for more, come to my poster later in the next room. Thank you.
I'm Bruce Howe, representing the Joint Task Force for Smart Cables. SMART is Science, Monitoring, and Reliable Telecommunications. The basic goal is to integrate environmental sensors into the trans-ocean, transcontinental submarine, commercial submarine telecommunications networks to produce a planetary sensor network to study climate, ocean, sea level rise, earthquakes and tsunamis. Crucial marriage between telecom and science here. The three sensors we're putting in are ocean bottom temperature, pressure, and seismic acceleration, the latter two directly related to CTBT goals. The first system will be installed in 2025 or 6. Portugal is fully funded, and it's underway, a system connecting Lisbon, Azores, Madeira, with a 4,000-kilometer long system with about 50 of these smart repeaters. Also, at the same time as providing environmental data, climate, and disaster risk reduction, this data will help protect the cable itself. The cables are presently deaf, dumb, and blind, and this will give them environmental awareness. When we succeed in doing this over the next decades, this will be truly a first-order addition to the Earth and Ocean Observing System. Thank you.
My name is Nick Ackerley. I'm with the Canadian Hazards Information Service. We're the NDC for Canada. My poster is about the value of fitting poles and zeros to calibration results. The top, you can see one of these calibration results in the lower left with good agreement between the measurements and the fitted results. And in the top right, you can see a plot of the percent change in the fitted response parameters with temperature at a test site near the Yellowknife seismic array. The horizontal axis is temperature, going from about -40 to +30. And some of the parameters are varying by up to 10% with respect to their room temperature values on the y-axis. And they match the temperature coefficients of these effects match their modeled values well. So calibration fitting like this can and should be routine. In this instance, the temperature sensitivity I'm talking about probably isn't affecting the ability of the arrays to detect and discriminate events, but the point is that if we can accurately track variations in these fitted parameters over time, we may be able to detect more serious problems early. So please come and see my poster at board number 22 if you want to come and talk about it. Thank you.
Good morning. My name is Benoît Doury. I'm with CTBTO Engineering and Development in the International Monitoring System Division. With this e-poster, I present CalixPy, software developed by the PTS for the calibration of infrasound systems. It works also with the seismic, but it was primarily developed for the infrasound. It is a key development in the implementation of the quality assurance infrastructure for IMS infrasound measurement, for acceptance testing, initial calibrations, and on-site calibrations. CalixPy is already running in the IDC. It is used since 2019 for the scheduled calibration of infrasound stations. It can be used as a standalone software and is integrated in NDC in a box, so it can be used also in a laboratory or on the field. Yes, in NDC in a box. Thank you.
Good morning. My name is Wolfgang Sommer. I'm with CTBTO at the IDC and responsible for NDC in a box and GeoTool. With this e-poster, I want to highlight some new capabilities that we made recently available, specifically when it comes to data import for IMS and non-IMS stations. So in this scenario, we walk you through a procedure where you import an REB event from the through VDMS from IDC with all the origin information, arrivals, waveforms that were used to define the event. And then you switch over to an FDSN web service provider that gives you information on non-IMS stations, where you can select, depending on the provider you choose, select the stations. GeoTool will automatically calculate the theoretical arrival times at those stations and import waveform segments from the FDSN service provider. And finally, you just place arrivals, you place the arrivals on the newly imported waveforms and relocate the event. And as you can see in the final screenshot, the error ellipse significantly decreased with these additional regional stations. Thank you.
Good morning. My name's Stuart Nipris from the UK NDC. The poster today that we'll be talking about at 11 o'clock, poster board number 27, we're going to be looking at the National Data Center Preparedness Exercises, the NPEs. These practice combined analysis of CTBT verification technologies and national technical means. The NPE 2019 provided a variety of opportunities to apply potential methods of an expert technical analysis using data from both IMS and non-IMS stations. So we reanalyzed the NPE 2019 seismic trigger events and other seismicity in this region, looking at why these events didn't make it into the IDC products. We locate the events, we perform event screening, cluster analysis, and look at P&S amplitude ratios. So if you want to chat more about this, please come and see me at poster board number 27 at 11 o'clock. Thanks.
Good morning. My name is Mario Villagran. I am presenting on behalf of the Office of the Director of the International Data Center. We have prepared for you a poster that is very much an open house to show you how the division works organically for all the tasks and duties that need to be performed. We have also prepared a snapshot of how the IDC commissioning is at the current moment, and also an explanation of the actual IDC operational pipeline for the production of the both automatic and manual review products. So we're going to be in the screen 28 waiting for you. And please, at 11:30 in Prince Eugen Hall, the IDC director will do a presentation on the 26 years development of the IDC. I hope you can enjoy both of them. We have prepared them for you to join us. Thank you very much.
Okay, good morning. I'm Nalin from Sri Lanka and OSI inspector. So this is just to make a point whether the protocol of the treaty is a hindrance for the OSI, because you can see the tools, technologies, and everything is just put into the protocol, and it was negotiated 30 years back. So the possible violator is not hindered by modern technology, but it is a point to see whether the inspectors are hindered by these old technologies, and when it comes to entry into force, I think the OSI people and the others has to sit and revisit and see whether the available techniques is appropriate to go ahead with developing science and technology. Thank you. I think it is about team building. And because in OSI is an environment, you can't build scenarios because you never know, you can't predict what will happen in a real OSI. So we see the last few years due to COVID and some other constraints, the team building happened to be something not very strong point, because the individual training is having a precedence over the team building, because in an environment, OSI environment, you never know what sort of eventualities you have to face, because scenarios could not be forecasted. So again, the team I am here to emphasize the team building capacity, because that will provide the better results for OSI environment. Thank you.
Good morning, ladies and gentlemen. My name is Yang Jing from China. Today, I will do the brief introduction about the radiation health and safety solution for inspection teams. Radiation health and safety is the most important element of inspection team. But do you know how to solve this problem? Both OSI training and integrated field exercise take into full consideration of it. Today, I will provide a systematic solution, including personal protection and monitoring equipment. And also today, I take the sample of lead-free radiation protection clothing. Everybody can look at it. It's based on flexible composite materials. And also it can provide lightweight and excellent wearing comfort protection solution in the real OSI environment. I think it is the advanced protection product in the market now. After that, we can provide many other different equipment for radiation monitoring. Everybody can look at the screen. If you have any other, if you want to get more information about it, please contact with me. Thanks for your attention.
Good morning. This is Luis, on-site inspection division. Do you agree with me that conducting an OSI is challenging? It's challenging, right? Do you agree that conducting an OSI in a mountainous environment is even more challenging? Yes, it is. Is it impossible? No. All right? And we know because we tried last September in the Austrian Alps within treaty constraints So if you want to hear plenty of adventures about driving in forest roads, carrying 60 kilos of equipment in your back while climbing a mountain, if you want to hear about flat tires, about storms, just please come and enjoy. Thank you.
Hello, my name is Remy Kobalkini. I'm working within the EP section of OSI. To follow up the speech from my colleague Luis, it's also a challenge to properly maintain, calibrate, and protect our equipment. This is a nice picture of the warehouse CTBTO has at Cybersdorf. And OSI has more than 200 tons of equipment, and part of this equipment must be properly maintained, calibrated, and protected. So we developed a series of tools to support us on a daily basis to make sure the equipment is maintained, make sure the calibration status is up to date, and to make sure we protect the access to the bonded area. So we have here on the slide a list of some tools. We have a database for the asset management. We set it a portal, RFID portal for the tracking the equipment movement. We have also a new two-factor authentication case-safe cabinet to make sure people have access to the bounded area with the good credentials. And I strongly recommend you to go to my board, number 36, I guess, and to go more in details about these supporting tools. Thank you very much.
So again, about OSI, and you can see in OSI you have to explore each and every avenue to come up with the fruitful results, because this is one of the areas that we have not focused much. When we are in a environment where the inspected state party is, the behavior of the inspected state parties, because we can broadly think about three scenarios, three events where an inspection will be called on, because one is could be a natural disaster, resembles a UNE, and the other one is going to be a nuclear accident, and the other one could be a real test. So in these three scenarios, the behavior of the ISP is going to be quite different. So just to try and add into our toolkit whether this behavior could be analyzed in a manner to identify what has really happened in the field. Thank you.
Good morning, everybody. These are photographs of the OSI Airborne Simulator. We've brought this facility to this particular conference this week. So hands up everybody who's seen the simulator in the exhibition downstairs. Hands up who's seen it. Okay, so very few. So I'd invite everybody who hasn't seen it, and even those who have been to see it, to go down and see it again, and to sit inside the simulator and to get an experience of the simulation that we provide our inspectors for training, and also how it assists us in the development and testing of OSI equipment. So I encourage you to see the poster and also our exhibit downstairs close to the entrance to this conference. Thank you very much.
GMO, radionuclide, sauna, Apex, Inspire, Spectra, OSI NDC in a box, Angular, centralized, complex, simple, legacy, advanced, data flow, integrated, chain of custody, sample management, OSI field laboratory. Some of these words are familiar and some are not. Intrigued? Come by the poster. My name is Jonathan.
A small announcement that I didn't do yet. It's if
we would like you to vote for the posters you like or for the oral presentation you like. You can do this by visiting the different contribution page on the app. For the posters, you can also scan the QR code that is on the poster that is displayed automatically. In the app, there is a scanner button. Just use the scanner of the app. That's the only way to vote. So please pass on the message to the other. If someone is asking you, you have to use the scanner in the app. And I think with this, Carl, can we start with the first one? Then we start with the first one. Thank you.
Hello, everyone. Hanan Mahmoud from Egyptian National Data Center. Our present study about design response spectra of some selected city along the northern western coast of Egypt by assessment of probabilistic seismic hazard analysis and making hazard map by different return period and different spectral period. Finally, calculating the response spectra of some selected city by considering all soil type, which mentioned in International Building Code. If you want to learn more about this, come to see my poster or access it online on SnT conference platform. Thank you.
Hello everyone, I'm Murad Hamimat from Jordan Seismological Observatory. I will present my presentation about improving location accuracy for seismic GT5 event in Jordan. I will highlight some about seismic Jordan seismicity and the main object of enhanced local velocity model using GT5 criteria. If you have any question, you can meet me tomorrow from 9 to 10 in board number 6. Thank you.
Hello, my name is Michael Bonneau. I'm from Los Alamos National Laboratory in the United States. And this poster is about using a consistent travel time framework to compare three-dimensional seismic velocity models for location accuracy. So we've worked on developing this framework to have fair and consistent comparisons between 3D velocity models for location accuracy. So it uses an open source framework, which is GeoTest, developed by Sandia National Laboratories, uses 3D tessellation points, and can easily store 3D travel time corrections and uncertainty for any three-dimensional model or ray tracing algorithm that can be used with a seismic location algorithm. The surfaces are built in the program called pCalc, which is also freely available. And so we created surfaces for all of the IMS primary and auxiliary seismic stations for PNS phases and several different 3D velocity models. And so there's an example there for the IMS station GERES for station phase P. And then there's some results from location results for different models and some validation events that were ground truth of 5 kilometers or better. I'm going to be at station number 2 tomorrow morning, so please come by if you would like to see the poster.
Hello, everybody. My name is István Bonder, and I'm presenting a poster on our collaborative work with Lawrence Livermore National Laboratory, Georgia, Armenia, and NDCs from neighboring countries. We collected a bulletin data by digitizing all the records, and we relocated the seismicity of the Caucasus region with the newly acquired data. And first, I relocated the data with iLoc, which is a single event locator. Then using the iLoc results and the ground truth events we identified with the single event locations, we relocated the entire seismicity with BaseLoc, which is a multiple event locator, locating simultaneously the entire seismicity. And the results allow us a better tectonic interpretation of the region. Thank you.
Good morning, everyone. I am Yasemin Korkusuz Öztürk, working as a postdoctoral researcher in Boğaziçi University. The Marmara region has been seismically silent since 257 years. Therefore, we expect a destructive earthquake on the main Marmara Fault, and which can strongly affect the Istanbul metropolitan. In order to obtain dynamic earthquake rupture simulations on the main Marmara Fault, in this study, we use two different stress accumulation techniques because it's the major issue for realistic dynamic rupture simulations. In the first technique, we manually multiply rigidity, slip deficit rate, and past time since last large earthquake. In the second technique, we are making quasi-static simulations by pulling two sliding blocks and calculated accumulated stress on the fault surfaces. We are already obtained dynamic rupture simulations using the first technique for the expected Marmara earthquake and for the already occurred 6th of February Kahramanmaraş earthquake. And we are currently working on the second technique. For more information, please come and see our poster on board 8. Thank you.
That's on me.
Hello. Good morning, everyone. I am Yasser Rawahi from Earthquake Monitoring Center from Oman. In this study, we are trying to study the seismicity of Oman, North Oman Mountain using a small aperture seismic array that was built in cooperation with the Lawrence Livermore National Laboratory. We are using a beamforming technique to detect some minor activity in the Oman Mountain. As it is shown, the Oman Mountain have been complex. It is a complex geological pattern. As oceanic ophiolite have been abducted on the Arabian platform, and we detect some minor seismic event, as well as man-made event. Come to see my poster tomorrow. Thank you.
Yeah, hello everyone. I'm Richard. I'm a PhD student at the University of Vienna. And everybody knows the devastating effects of earthquakes. And my research is about to understand how daily processes changes the crust, because we want to work towards the direction of understanding initial phases or precursor phases of earthquakes. So if you're interested in how CTBT arrays can be helpful to understand these kind of basic processes, come by my poster tomorrow on screen 17. Thank you.
My name is Artie Rogers. I'm a seismologist at Lawrence Livermore Lab, and this talk is about developing Earth models for physical simulations of seismic waveforms using adjoint tomography. And adjoint tomography can provide these models for forward and inverse modeling, such as moment tensors. And we've used these models to infer moment tensors of sources with the idea that we can remove path effects and not have to shift our seismograms. We've worked on the Western United States, where we have copious open data and former earthquakes and explosions at the former Nevada test site. And we've also started working in the Middle East and Southwest Asia. And we find that our models provide better fits to the observed data, and that we find we get more improvements in the fits to the data from developments in the Earth models compared to moment tensor inversions or source inversions. So this demonstrates the value of adjoint tomography for coming up with new models to simulate earthquakes or unknown events, and can be useful for monitoring in the future. Thank you.
Good morning, everyone. First of all, it was my mistake that I thought I was supposed to prepare a slide with a recorded audio. That's why my slide here looks very different with others. By the way, my name is Zulfaka. I'm from Malaysia. As you may notice from the title of my poster here, for this particular study, we use the IMS seismic data to quantify the recurrence periods and probabilities of occurrence of earthquake in Sabah region, where Sabah is known as prone to seismic activity as compared to other parts of Malaysia. And these preliminary findings are useful to further understanding the seismic of the region. And with that, I welcome all of you to visit my poster tomorrow for further information and discussion. Thank you.
Hello everyone, I'm Mona Abdelazim Abdullah. I'm a researcher assistant at Egyptian National Data Center in Riyadh. Our study focused on studying the seismotectonic setting of very important city in Egypt. It's Aswan. So we calculated the stress tensor inversion for earthquake happened in the vicinity of this region. Also updated the focal mechanism catalog. And also we calculated the column stress change for the largest earthquake happened in this region. If you're interested, you can visit our poster. Thank you.
Hello everyone, my name is Raluca Dinescu, I'm from Romania. My presentation is about obtaining an improved 1D velocity model for the Southern Carpathian area using data from local earthquakes. The purposes of my study are to use the best algorithm to obtain the 1D velocity model and the station corrections, to relocate the events from the study area in order to get a better tectonic characterization, and to apply the improved velocity model for relocate known blasts and new events. For more info, you are welcome to poster 33, to position 33. Thank you.
Hello, my name is Andreea Chircea. I'm a geophysicist engineer and I work as a junior researcher for Romania NDC, hosted by the National Institute for Earth Physics. And my present study is the contribution of the auxiliary seismic station MELRE in IDC products. And also, I've conducted a comparison of the IDC review event bulletins and the NDC Romania bulletins. My study has two main purposes, as I said, to analyze and highlight the contribution of MELRE station in the IDC products for local and regional earthquakes. And my main subject is to compare the reviewed seismic bulletins produced by RomNDC with the REBs produced by IDC. For more methods, results, and conclusion, I'll be waiting for you at board 34. Thank you very much.
Hi, I'm Nishad Raju Ranasinghe from Los Alamos National Laboratory. So at Los Alamos, we looked at two sites in Nevada test site to look at the gravity. One is Aqueduct Mesa, that is a site with tunnels, and we looked at whether we can use gravity to characterize the tunnels. And the Rock Valley site, that is a site for a future experiment where we were doing the site characterization. So this is our two models. This is the Aqueduct Mesa. We obtained the gravity measurements in 2018, and this is the geological framework model. So we are looking at can we use gravity to identify voids underground. So these some of the results. This is our forward model, and this is the observed model. The forward model actually matches well with the observed model, and we are doing inversion and forward modeling using a Simplex software. So we are currently developing this software and doing inversion and forward modeling. Please come to our poster. Thank you.
Hi guys, my name is Tirian Banara Kutunjaipe. I'm a researcher from Madagascar at the Institute and Observatory Geophysics of Antananarivo. Today I'm going to show you guys the result of my study, which is titled about probabilistic seismic hazard studies. Different steps were made to acquire results from my studies, which are preparation of the earthquake catalog from 1975 till 2016, then homogenization of the catalog. After that, I did recurrence parameters determination using Gutenberg-Richter equation, then magnitude maximum assessment. After I plotted the seismic hazard assessment using logic tree method. If you want to learn more about my result, please feel free come into my e-poster during this session. Thank you.
Hello everyone, I'm Yonki. I'm a PhD student at the University of Vienna. I'd like to present our work about the application of nonlinear elasticity to resolve the maximum horizontal compressive stress or SHMAP orientation at the Earth crust. We emulate laboratory protocols to perform the so-called natural pump probe experiment, utilizing the solid oxide as low frequency vibration and empirical green function from ambient noise correlation as the high frequency probe. The method is validated using large-scale dense seismic networks in the northern Alpine foreland, where the orientation of SHMAC is well known from borehole-based measurements. And then we apply the method to the southern Alps to address equation why are some faults in the app active and others not? I'd like to invite you to my poster, and then we discuss it more. And thank you for your attention.
Hello, everybody. I'm Benoît Derode, and I'm working for the IRAP laboratory in France and the CEA Dam on observational seismology and on development of deep learning methods. Because as for lots of topics, seismology is facing these last years a huge increase in the density of instrumental networks and of the data they generate. Then if we want to take advantages of this vast amount of information provided by the different sensors, networks that we have, we will need to develop new methods and integrative protocols to collect and process seismic records. Then in our e-poster, we will present some work and some of the benefits of using a couple deep learning-based methods to create integrative protocols for detecting, locating, and characterizing and discriminating the seismic events in different tectonic contexts and different instrumental contexts for scientific studies or for operational use. Then I will be happy to present this work or talk with you if you're interested. Thank you.
Good morning. My name is Patricia Pedraza from Colombia. We analyze my miniature microseismic arrays in the primary seismic station. I invited you to visit my e-poster and in the number 52. Thank you.
Welcome, everybody. My name is Ronnie Quintero from Costa Rica. In this e-poster, I will present you the use of local data to answer some of the questions about the earthquake location. Some of the questions that arise using global data that we can elucidate or we can answer using local data. In the e-poster on the board 52, you can learn more about this earthquake that happened in July 21, 2 years ago. Thank you.
So, good morning. My name is Tommy Vuorinen, and I work at the Institute of Seismology at the University of Helsinki. And my e-poster tomorrow, it's echo, is to kind of like do this, apply this template matching algorithm we developed for this induced seismicity from enhanced geothermal system to regular Fennoscandian earthquakes. And our purpose is to kind of like map whether there are before or aftershocks of these larger Fennoscandian events. And if you want to know more about the study or the method, come and see the poster tomorrow. Thank you.
Hi everyone, good afternoon. I'm Adila from Indonesia. In this occasion, I want to present our research. The title is Seismic Source Modeling for the 2018 Lombok Earthquake Sequence Estimated from the Empirical Green's Function Method. In 2018, a series of earthquakes occurred in Lombok. The foreshock with magnitude 6.4, the main shock with magnitude 7.0, and the largest aftershock with magnitude 6.9. This earthquake is so unique. Therefore, we try to apply empirical Green's function to conduct source modeling to capture the rupture and aftershock direction. By processing the data, we obtain the SMGA location, indicate the rupture direction is going to the southeast direction, which is in line with the aftershock distribution. Therefore, we can conclude that the empirical Green's function method has been successfully applied to conduct source modeling, which is important for seismic hazard assessment. That's all for me. Thank you.